Very exciting.
I was tired of sleeping.
I fell asleep.
Nice. Love it. Any other updates?
I'm building a Lego set.
Ooh, fun. Which set?
It's Hedwig, and she's standing on some books with like some oceans.
Take it to college with you?
Probably. If I remember.
Okay, here we go. So yesterday we left off on this little paragraph. So we said that a reaction that's second order has a rate equation of K equals A times B. Could be carried out with a very, very large concentration of one reactant compared to the other. So when this happens, the reactant with the large concentration will be constant because its concentration will change so little. So what I'm saying is when you have so much of one, the concentration is not going to change. It's going to just be constant. And because of that, so let's say it's B that has a huge concentration compared to A, you really just write the rate law as K equals A because B isn't changing. That's all that was saying. So because one is so big, you don't even put it in the rate law. This is a very, very, I don't think you'll see that on an AP test, but I just want to put it on there. Okay? So now you can't say I didn't say it. So there it is. Okay. Identify the catalyst and the intermediate. Let's square the catalyst and let's circle the intermediate in the following. Square the catalyst, circle the intermediate. I got homework problems ready to write up. Are you guys going to do homework problems this weekend?
No.
Okay. Sounds good.
What?
What?
When's the test?
Not for like another. It's not next week.
It's 2 weeks away from yesterday.
We do have a lab Monday. So bring your Chromebook
Oh no.
and we'll have lunch here. Yes, goggles.
Hey, they kind of screwed us over with those Chromebooks. We got the
I heard that the juniors was nicer.
Yes.
Yeah.
Yeah, they are.
But like they're going to get to keep theirs longer.
I don't
Yeah.
care.
So that makes
Mine
sense.
still has white crumbs on it though, so that annoys me.
Yours has what?
Like white crud and crumbs in like the
Yeah.
bar. and
Mine
stuff.
feels
Yeah.
slimy. I don't like mine.
All right, catalyst. Did you square? V2O5.
Yeah.
That's my catalyst. And my intermediate was? All right, flip it. Nice. Okay, another example. So I have the chemical reaction. W plus Y equals Z has the following sequence of steps. Step 1, W goes to R. That's the slow rate determining step. Step 2, R plus Y goes to Q. It's fast. Step 3, Q goes to Z. That's fast. Here, the rate only depends on the concentration of what? W. Since it's the only reactant, sorry, there's not a lot of room, in the rate determining step. So the rate equation for this would be rate equals K times what? Concentration of W. And then the order with respect to W would be 1. Example 2. This one's a little trickier. The chemical reaction A plus B yields C plus D has the following sequence of steps. Step 1, A is in equilibrium with Q. Step 2, Q plus B yields C plus D, which that is the slow rate determining step. So the slow step contains what? Q and B. So the rate would equal what? Rate equals K times concentration of Q times concentration of B. But there's a problem here. What's the problem? What? There's an intermediate. All right? Q is an intermediate, which means its concentration is basically impossible to isolate, calculate, whatever you want to say there. Because we know the intermediate is made and then gone. All right? So you basically cannot get that concentration of the intermediate. So we have to switch Q with something else from that equation. And because, that was very dramatic. And because Q is in equilibrium, which means it can go both ways, with A, they can be switched. So the rate law is actually going to be rate equals K times A times B.
So I was right.
So you were right. On accident. So,
Wait, what's the one under Q?
what's that?
What's the one under butt?
Under but.
Yeah.
Isolate.
So this is like geometry proofs.
Ah, kind of. A little bit. Don't think about it like that, though, okay? This is not. Let's not bring proofs into chemistry.
My brain just
All right?
that's always what I go to with transition.
But if you can think about it like that, that's fine. My wife made a new recipe this week. It was like these pork meatballs and this like, what's it called, a bang bang sauce? And it was like very garlicky. And it was the point that it was so garlicky that it like tickled your tongue. Like, have you ever had something so garlicky that it like tickles your tongue, like almost?
It's good. I like
It almost tasted spicy.
I've never had a tickled tongue sensation.
Well, you would have.
You didn't know what suds were.
You would have.
Yeah,
Why are we bashing on Ashan right now?
Tickled tongue sensation.
You didn't know what suds were?
When you said suds and I kept saying it, he's like,
All right.
I don't know what that is.
Here we go. Let's do some brain thinking.
Yes.
Let's do some brain thinking. Example 3. Conceptually, rates can be determined pretty easily with some brain thinking. So here's an equation. BrO3, it's in solution, plus 5 Brs plus 6H, yields 3 Br2 plus 3H2O, la-di-da-da. The results of 4 separate experiments. Because remember, I said yesterday, rates have to be determined experimentally, right? Are given in this table below. And by inspecting the initial rate data, it's possible to determine the rate equation, and since the rate equation and mechanism are inexorably linked. I don't know why I use such a big word there, all right? Because I guess I wanted to sound smart. All right?
No, it's not you.
To deduce information about the mechanism. So, here's what you're going to do. Flip the page. Because I copied it on the next page as well. Same table. So, if you can determine a rate law by inspection. So, if you're going to determine a rate law, other concentrations must be held what? Something's going to have to stay what?
Constant.
The constant or the same. You got it. So something is going to have to stay constant. So let's say I'm comparing the results of A and B. Okay? By A and B. By doubling the concentration of BrO3. So if I take my BrO3 minus, right? If I double BrO3, so I'm looking at A and B. Do you see how my concentration doubled? Yes? You suppose?
Yeah.
All right. Do you see how that went times 2?
Yes.
Yes.
That also doubles the rate, because you would agree that the rate also doubled. Yes? Went from 10 to 20. Yes? Therefore, the rate of BrO3 is said to be, well, what order would that be? It would be first order.
Yeah.
It would be first order because it's just it's an even double, right? It's an even double. If I look at B and C, doubling, what's doubling on B and C? The concentration of Br. Doubling the concentration of Br minus does what to my rate? And we're from 20 to 40, so it doubled it. That doubles the rate. Therefore, the rate of Br is said to be first order. First order. Comparing C to D, doubling the concentration of H plus, concentration of H plus does what to my rate? Quadruples. Quadruples the rate. Therefore, the rate of H plus is said to be second order, right? Because you're essentially raising it to the power of 2. That's how you get the quadruple, right? First order, raising it to power 1, you're just doubling it, all right? Here, I'm quadrupling it. So if I was going to write the rate equation for this, I would say rate equals K times the constant. So now we're going to put actual things in here, not just A, B, C anymore. Times the concentration of BrO3 minus times the concentration of, ooh, that bang bang sauce is hitting. Oh. I just got this weird pain in my stomach. Ooh. Hopefully we're going to make it. Times the concentration of H plus squared. right? Am I going to show a to the power of 1? No, we're not going to show that. So now I could say, let's solve for k. So we're going to pick any one trial, which I usually just choose the first one. So now we have to sub our numbers in. So I'm going to say rate. What is my rate? My rate is 10 what? 10 m
Yeah.
per t, right? 10 m per t equals concentration of BrO3, which is 0.0050 molar, times the concentration of Br, which is 0.025 molar, right? Times the concentration of H squared, which is going to be 0.030 molar squared. So solve for K and tell me the units. Solve for K and tell me the units. Solve for K and tell me the units.
It's KT. No, K is. Sorry.
Is KT? What do you mean?
I think I figured it out. I don't know why.
We forgot to write K in here.
Yeah, I was trying to find K.
Here's
Did
K.
we
K
move
should have
it
still
over?
been in here. I
Yeah.
forgot to write it.
I was
So
making
K
sure.
would be here.
Okay.
Solving for K. It should be a big number.
It is.
Did you get a big number?
Yes.
Yeah.
Kel, what'd you get?
2 with a lot of 6s.
That's not what I got.
I got a lot of 8s.
8.9 times 10 to the 7.
I had 8.9 times 10 to the 7. So check your math. So it's going to be this times this squared.
Oh, cute.
All right? And now, units, right? I've got molar, molar, molar squared, right? So that's molar to the 4th. And I've got 1 molar on the top, right? So I'm taking a molar, I'm going to divide it by a molar to the 4th. So I'm going to end up with molar to the negative 3rd, right?
Yeah.
Yes? And then, did the t change? No. So I write it like this. You can write it like this. T to the negative 1, m to the negative 3, right? Or you can just do this and then over t m cubed. Either one's okay. Does that make sense how I did it?
What did I do?
So I did t to the negative 1, m to the negative 3, or you can just do 8.9 times 10 to the negative 7th over t times m cubed. So you can see that the units get a little weird. Units get a little bit weird. You guys cool with that? Okay. So that's how you kind of do it by inspection. And a lot of you are going to be like, I got it. Okay?
I do not do it.
But some of you may want to see the actual math, how to do it. So I'm going to do the actual math too. So here we go. So this can be done mathematically too. So here's our new example. All right. Did I ever tell you I lost the word mathematical in 6th grade, my spelling bee?
Oh.
I spelled it M-A-T-H-A.
Oh.
Yeah. And I would have won because I knew every word after that. And we don't know what the consolation prize was after I walked off the stage.
A water bottle.
A peanut.
It's like a peanut, like.
Mr. Pierman was my 6th grade teacher. Anybody have him? Probably not.
Mr.
I don't think so.
Gave me a peanut after you left.
A
Lost.
single.
Honestly,
Like a peanut or
understandable.
like in a shell?
In a shell.
Oh, okay.
That's worse than no prize.
I would rather have just said good job, but I ate it. So, anyways. So here's how you can set this up mathematically. Okay. So if you're not like seeing it conceptually, that's fine. Here's how I set this up. So first thing I like to do is I like to put the bigger number on top. Okay. Can you do this with a smaller number on top? Yes. It just makes your math harder. So I would set up like this. Rate 2. I'm going to take rate 2 equals 4, right? which is going to equal K, times the concentration of, I'm going to start out with 0.0100. I don't even put units into this, by the way. Okay? Don't even worry about units. I do that later as a separate step. To the x times 0.0250 to the y over rate 1, which is going to equal 1, which is going to equal K, times the concentration of 0.00500 to the x over 0.0250 to the y. Do you see how we're going to easily cancel out some units here? K is going to cancel out. This is going to cancel out, right? Leaving me 0.01 divided by 0.05, yes? And 4 divided by 1. So this is essentially saying that 4 equals 2 to the what power? 4 equals 2 to the x, right? Yes?
Yeah.
So what does x equal?
2.
X equals 2. Now, could you see that with your eyes and figure that out? Yeah, you could. But here's the math behind it as well. Then, to figure out y, we have to hold the other thing constant, right? So to figure out y, now I have to hold x constant. So I'm going to have to use rate 3, and I'm going to use experiment 3 and experiment what?
1.
Yeah. So, let's see, experiment 1 is bigger, so I'm going to put that one on top. So rate 1 equals, what is that? 1, which equals K times the concentration of 0.0500 to the x times 0.0250 to the y divided by rate 3, which equals also 1, which equals K times the concentration of 0.0500 to the x times the concentration of 0.0125 to the y. So, gone, 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 gone. So this is saying that 1 divided by 1 is 1, which equals 2 to the y. So y equals 0. So y equals 0.
So it doesn't affect the...
Correct, so it does not affect. So what is my rate law going to be for this? I would say rate equals K times concentration of x to the second. So that is how you do it with math. It's what we just did in our heads, just with the math. So there that is. Questions on that? Can I flip the page? All right, I'm flipping it. So here you guys go. I want you to write the rate law. Tell me what the overall, I'll tell you what I want you to do. I want you to write the rate law. That's number 1. Number 2, give. What in the world? Give the overall rate number. So what's the overall rate for the whole reaction? Solve for K is number 3. So this will probably take 5-7 minutes to do this. So write the rate law. Give the overall rate. Solve for K. Yeah, we didn't do that on the last one. The overall rate for the last one would have been 2, right? Because we had nothing to add together. So I'm saying when you add up all the exponents, that's the overall rate.
Overall order?
The order, yes, sorry. The order. The overall order. Give overall order. That makes more sense. It's when you add up all those exponents. The overall order. I also don't care how you do this. You just need to show something, some kind of work. So like, as this doubles, the other doubles, something like that. I like your tie, Vince.
Thank you.
Doesn't that teal look good? Yeah. It's not that I don't like your tie, Eric.
Mine's cool.
I'm gonna give you guys like a 5-minute head start. I'm gonna start my work. You guys keep going.
Wait, which way are you doing yours? The math way?
I'm doing the math way.
Okay.
I always am gonna do the math way.
I'm gonna see how you start this because I feel like I got it instantly wrong. How far are you? I didn't see them. Oh no, I'm not.
Now
No,
remember,
you're
you
still-
can do the small over the big.
I did.
It'll work.
Yeah.
Your numbers are just gonna be worse.
Yeah.
It's just really big and good. Wait, why is that one backwards?
I don't know why I wrote it backwards.
Okay.
I just wrote Y
I was
first.
so worried that I did something wrong.
I just did it. That's why I don't know why I did it like that.
Actually, let's
2 equals 2 to
Is
the
this
x.
canceled underneath?
What's that?
I was trying to see why you wrote it backwards, but I should
X equals 1.
try to
And this one, 2 equals 2 to the y. So y equals 1. So rate equals k. Concentration of A times the concentration of B. Right? Overall order is second. Second order, right? 1 plus 1 is 2. And then here comes my other step, my k. So I'm gonna sub in. I'm just gonna do the first one. So 1 point. I don't even need the point. 1 molar second to the negative 1 equals k times the concentration of 0.005 molar times the concentration of 0.025 molar. I got k equals 8,000 over molars times second, or 8,000 m to the negative 1 s to the negative 1. 8,000 m to the negative 1 s to the negative 1. How'd you guys do? Good? Now the units get wacky when as soon as we're getting up to like doubles, like second order, more than that, the units get a little bit weirder, but that's it, all right? When you're doing a rate law, oh, that's not it, all right?
Oh.
That's it for a regular rate law. Questions on that? Yes?
Is 8,005 for sig digs, or do you need like 8.00 times 10?
I'm not grading sig digs on that.
Okay.
You're not going to be doing sig digs on a rate law question.
Okay.
So, sig digs will be something where you're measuring. So,
Okay, that's true.
I don't care about sig digs on this. Yes?
For the free response on the exam, will we count students?
There is 1 point for sig digs on the exam,
The whole thing?
on the whole thing. And it's going to be probably one where you're looking at some like burette or something where you're measuring. So, you have to do it on all of them because you don't know which one the 1 point is. So, but there's one sig dig point. That would be a silly point to miss. So yeah.
But then it saves the trouble.
Flip it. Flip it.
1 point over time.
So using the rate equation in question number 1, that was rate equals kx squared, right? What we just did. Which of the following proposed mechanisms is valid? Which of the proposed mechanisms is valid? So mechanism 1 or mechanism 2, and don't overthink this. All right? Don't overthink this. There's only one that there should be one that you should immediately think it's got to be that one. Seth says, Which one, Seth?
I thought it'd be the second.
Why?
It has the cool symbol.
Yeah.
Has the cool symbol. No.
Yeah.
Well, guys, I'm all out of ideas.
I know that it's second order, right? So how many molecules am I going to have on the left side?
2.
And what also do I have to have in the reactants? X. And that also has to be in the rate determining step, yes? So it has to be mechanism number 2. Because the rate determining step, yes, has to have the X in it. Has to have the X in it. And it's also second order, so I know I have to have 2 things.
Why does the rate determining step have to have X?
Because remember yesterday we talked about it. The rate determining step is the one that you're basing your rate law off of.
Right.
So it has to have what you're actually going for in it. It must.
Why are we
So it
got,
has to be in the reactants?
It has to be in the reactants. Products don't matter.
why X instead of A or B?
Because the rate law was K is X squared. This was the rate law we were using.
Okay.
If it was A, it was not worth either.
If it was A,
It would be okay.
if it was A, then it would have to be mechanism number 1, right?
Oh,
Because
I
you have to
mean,
have A in the
If
reactants.
it had A plus B to Y in step 2 of mechanism 2, since they're in equilibrium, does that
Well, that would change it, yeah.
that would
That
work?
would change it,
It would
yes.
be okay.
Yeah.
Okay. Even if rate was still K.
Correct.
Concentration. Okay.
Marin.
So like whenever we're doing like the rate laws and the rate order and like finding K, like
Yes.
in number 2, I didn't like look at the equation. Was I supposed to? Okay.
You don't have to. Yeah. Allison.
So the fast steps are like instantaneous?
Essentially, it doesn't really, the fast steps don't matter because it all depends on the slow step. It's a slow step that matters for the rate law. So when you're doing the rate law, because this is X, X has to be in the slow step. That's what you have to know. Okay? By the way, what was X in proposed mechanism number 2? X was actually a what? Actually an intermediate, right? It was actually an intermediate. Actually an intermediate. Okay. Let's do some more fun stuff. Flip it. This is real chemistry. Now we're going to the integrated rate law. So, hence your calculator. Yes. Integrated rate law. So, this relates concentration to reaction time. So the order of a reaction, the order of a rate law, is going to be either 0, 1, or 2, is determined by what variation of the concentration versus time on a graph creates a straight line. So which one of these create a straight line? So we have concentration versus time, we have natural log of the concentration versus time, and we have 1 over concentration versus time. So let's just draw 3 little mini graphs. If I have the concentration of A, and I have time down here, and that creates a straight line, that is 0 order. You're almost never going to see that. All right? AP is not going to give you a 0 order. You could, but I've never seen it. If you have the natural log of the concentration of A over time, and that gives you a straight line, That is first order. That is first order. And if you have 1 over the concentration of A, and that gives me a straight line versus time, this is second order. That is second order. Guess how you have to determine this? You got to graph it, right? So you're going to have a set of data, and you're going to have to graph it. So a rate is going to equal a change, which is going to be a decrease in the concentration of reactants over time, right? Or triangle, change in concentration of A over T, over change in T. So that's triangle concentration of A over triangle concentration of T. This means the slope on the graph is going to equal what? K, the rate constant. So because it's change in concentration over change in time, the slope of the graph is going to equal K, right? Which means y equals mx plus b is going to be essential. So open up your book to page 480. 480. Get your calculator out. 480, get your calculator out. So,
Yeah, every day that I bring it, we don't use it, and every day that we have it.
480. Look at the graph, at the chart, at the top of page 480. Do you see that N2O2, 0.1, 0.07, all that stuff? Yes?
Yes.
Okay. Have you guys graphed recently on your calculator?
Yes.
Okay. Is your stat plot on?
No idea.
So I'm going to go to, I go to stat, I go to edit, or no, that's not stat plot. I go to second stat plot. Is your stat plot on?
It's supposed to be.
It should be. All right.
How do you do that?
I just hit enter and make sure it's on. Make sure it's on. And then for me, my X list is L1 and my Y list is L2. So you got to know what's what. You guys good with that setup?
Say that again,
No.
sorry.
So is your stat plot on?
Yep.
No.
Yes.
No.
So turn it on.
How do you turn it on?
I went to second stat plot.
Second, and this button on.
Mine is a TI-83 plus. Okay, that's the same thing I've had since high school. And then it doesn't matter as long as you know, but for me I like to make my X L1 and my Y L2, just because that's usually how you enter data, X then Y. Are you guys good with that? Okay, so we're gonna go to stat. Hit stat, then you're gonna hit edit. And I want to type in the data as it is. So on my L1, I'm going to type in all of my times. So 0, 0, 50, 100, 200, 300, and 400. Then I'm going to go into my L2 and I'm going to type in all of my initial concentrations, 0.1, 0.0707, 0.05. I'm going to stop talking so you guys can do this on your own. 0.0125. And then 0.00625. I have my data typed in. So you have your data typed in. So I'm typing it in as is. If this, when I graph it, gives me a straight line, what order is this going to be? Zero order. All right? If this gives me a straight line, this is going to be zero order. Do you have your data typed in?
Yeah.
Do you guys know how to make it go to graph? I hit zoom 9. That's what I do. Whatever you need to do for yours, make it graph it. For me, I hit zoom 9. Is that a straight line?
No.
That's a curve. Agreed?
Yep.
Do you have a curved line like this?
Yeah.
I do.
I'm pausing. Making sure everybody has a curved line.
It's not a zero.
So it's not zero order. It's not zero order. Did you guys get a curved line?
Yes.
No.
How do we put a line
You
calculator?
said no.
Imagine it.
You're 7-7. Wait, what'd you do? You said your legs are so legs. You did legs obviously.
I don't know. I did a lot.
Imagine.
Leg extension.
Or
Bulgarian.
Bulgarian what suck.
Leg press.
Oh, okay.
You're
You know what I did? It was on and then I thought it was off, so I turned it off.
Do we get to this part?
Yep.
So, Jacob?
Yeah.
Okay. Now we need to take, I'm going to go back to my, you guys good over here?
Do the other one.
Yes? I'm going to go back to my stat, edit, and I need to take the natural log of list 2. Agreed?
I agree.
So I'm going to go up to my list 2. I'm going to hit enter. And do you see how my cursor is down here? I'm going to hit second, insert,
So the time is also.
natural log. Hit enter.
No way.
Boom. Now I've got all natural logs of the whole list.
Ooh, it is a string.
All right? So have it do it for the whole list, right? Do not take natural logs of all those individually. Were you guys okay with the insert, what I just did?
Yeah, I was helping.
Okay. So I went up to L2, I hit enter, then I went down here and I hit second insert natural log, enter, and then it gave me the natural log of all of those.
Okay.
Should also be the same as chart number 2 in your book.
Yes.
Yes? But I wanted you guys to do this. Kale, you caught up?
Yeah.
Molly, Marin?
Getting there.
Okay. Oh, you're using your phone.
It did work,
Good,
but
good.
yeah.
Is there a shortcut to do it if it's the inverse, like the 1 over y? Something like.
Yeah, I would just do second insert 1 divided by,
Oh.
right?
Mm-hmm.
Yeah. 1 divided by the list. Now, usually it's going to be, what I would do on the AP test, I would assume, I would check to see if it's first order, and then I would see if it's second order. Don't even mess with 0 order. It's probably not going to be 0 order.
If it's not first order or 0 order, can you just assume that it's second order?
Yeah,
See, there's no other option.
What?
no other options.
So really, at that point, it's like it's first or
That
second.
should not
Yeah.
be possible.
So I would start with first order,
Yeah.
and then I would check and make sure it's second order.
Okay.
That's most likely not going to be 0.
Yeah, I guess on the AP test, you still want to check. Just.
You gotta check. You gotta check. Okay, so are we caught up to this point?
Yes.
Now I want my line. So I'm gonna go to stat, calc, and I want linear regression. So for me that's 4. So I went to stat calc 4. I'm gonna hit, so then it says linear regression, AXB, hit enter, boom, there is what I need. Alright?
See, we do need the
I went to stat, calc, and for me it was linear regression number 4, and then I hit enter. Do you guys have the same as what I do?
Yes.
Remember doing
Yes?
stats
Yes.
Done this in stats.
back in the day,
I'm gonna sneeze, I think.
3 years ago.
Go to calculate.
What is it?
Linear
A plus BX? Or no,
What?
AX plus B.
X plus B.
I have like 5.
Well, that's weird. This must be.
Figured it out.
Are you with me?
This must be a stats thing.
Yes? Okay. So, y equals mx plus b. So for us, y equals
MX plus B.
negative 0.00693x plus negative, parentheses, negative 2 point, however you want to do that,
Yeah.
303. Doesn't matter. So I know that my rate, constant, right? K is going to be,
Negative.
so there's something I got to give you. And the AP test will also give this to you. So, little sheet of constants. Because on a first order, it's actually the negative of K.
Oh.
It's actually, wait, what did I just give you?
Scrap paper or something? I don't know. Just
give you a cut up piece of
It's a cut up piece of
test.
the chapter 10 test.
I don't know how that helps you.
It should.
This is the whole test.
Oh.
This does not help you.
Allegedly.
Here you go. So AP Chem test gives this to you.
Nice.
Alright? Hence that's why I'm giving it to you.
I see.
Hopefully I have enough now. So, check it out.
Oh,
So on a first order, you can see that slope is negative k. So, did everybody get one of these?
Yes. Oh, this
So for this, what is my k going to equal because this is first order? 0.00693. Yes. So this is going to be 0.00693. You got it.
Is it just a coincidence that t of the 1/2 equals 0.693 over k? We have like a constant sheet for half-life.
Is that a coincidence?
Yeah.
I think not.
Wait, what?
That's a coincidence.
That is a coincidence?
Yes.
What a coincidence.
All right, because I was going to ask you to now solve for the half-life. So the 1 half-life is going to be 0.693. This is from the sheet, from the half sheet, divided by k, which for us, a half-life is going to be 0.693 divided by 0.00693, which is going to equal 100 seconds. So the half-life of this equation is 100 seconds. I could also ask you how much of A is left at 250 seconds. Guess how I'm going to solve for this? Take a look at your half sheet. The integrated rate law for a first order reaction. You got it. So, not hard. As long as you get the right graph, everything else is given to you. So, I'm going to write my equation for a first order integrated rate law. It's natural log of the concentration of A is equal to negative KT plus the natural log of A0. What is A0 going to represent? The initial concentration, right? So, the natural log of A is going to equal, now it's going to be the negative of the K, right? Because my K was positive, yes? So now it's going back to the negative. So negative 0.00693 times, my time is 250 seconds, plus the natural log of, what was my initial concentration? The time.
0.1000.
You guys agree at time 0 on the chart, it says 0.100. You guys okay with that?
Yes.
I'm not just pulling numbers out of the air. Yes?
It's on the.
In the book, at time 0, it is 0.100 molar. Now, can you guys do math? All right.
Is that times 250?
So you can't use your calculator for this because it's its own equation.
What do you mean?
Like you couldn't go to, like if I go to the graph and then I go
No.
calc, because it's its own thing.
This
It's
is
not
its
using
own
the
integrated
equation.
rate law. Yeah.
Because that's using the old equation.
Right.
Okay.
So do we get graphing calculators?
Yes. Yes. You must have a graphing calculator on the exam. And you get to use it on the multiple choice now too.
Yay.
So
Is that new?
that is new.
If you don't
I think because last year everyone complained about the multiple choice being so hard. Because everyone was like the FRQs were easy. Multiple choice is hard. So now it's like, okay, now it's on you.
Oh wait, is it two?
Now it's going to be balanced.
I got a negative number too.
You got a negative number?
Yeah.
No, that's the natural log of A. A is equal to E to that. I got a
But
I got a
the way
positive
you
number.
wrote it was,
Wait.
I got 0.0176.
yeah.
I got 0.0177 molar,
Yes. Yeah.
right? I showed
It's
my
just
work.
The third step, you had it positive, and it was tripping us out.
Yeah.
Oh, this is negative.
Yeah.
Okay.
Oh, okay.
That should be negative.
Just can't do
Okay.
that.
I did.
I
So-
still didn't.
Okay, Sean.
Okay.
E to the negative 4.0305.
Yeah, and I'd be still getting the wrong number. I don't think I've ever been able to use a calculator.
Have Aubrey show you.
I thought you wanted to do it.
That's why you got a partner.
How would you not do it?
It's the opposite. Reverse it with E.
What's that about?
E to the ln of x is x.
One last thing I want to write down. First order half-life. Oh, this is perfect timing. Does not depend on what? Look at your half sheet. Your first order half-life does not depend on what?
A.
Concentration.
Oh, okay.
It does not depend on concentration. That's the only one. The other thing I want to give you guys is kind of what all these half-lives look like. You won't get to use this on the test, but it's just kind of nice to see visually what these half-lives look like for each one of these. Oh, there's one other thing I want you guys to write down before we leave. This will help you with units. Shoot, does somebody have two?
Oh my goodness.
Sorry, Eric, you don't get one.
Sucks to suck.
I'll get you one. I don't know how that happened.
Yeah.
The last thing I want you to write down. Units on first order are always whatever the time is to the negative 1. Always. The units on, what's that?
For K.
For K. Yeah. The units on the first order K are always the time, whatever the time is to the negative 1. So if it's concentration versus seconds, the units are going to be seconds to the negative 1. If it's concentration versus minutes, it's going to be minutes to the negative 1. So that's just a little freebie for you there to help you with units. So Monday, we're going to have a reaction that you're going to run. And you are going to time this reaction, all right, at these different concentrations. Then you're going to graph it. And you're going to see, is it 0 order, first order, or second order? Also, that's it for the chapter.
Oh, yeah.
0, 1, 2.
So then, what does it mean, like, when you do the exponents?
That's the overall order of a reaction. When we're talking about the integrated rate law, there's only 0, 1, 2. Don't get the integrated rate law with regular rate laws confused. They're separate. So integrated rate law, you got a graph, only 0, 1, 2. Regular rate laws are different.
Anything more than one time?
Also, that was all of Unit 5. That is the chapter. That's the notes. So, we'll be doing practice, labs, next week. Yeah.
But not all of it is.
I think I got a lab next week and a lab the week after that planned. So, that was perfect timing. Eric, I will get you one of those. Actually, can I have one of yours back? I'll just make a copy for Monday. I would keep, Kale put his little half sheet in the front of his binder. That's smart, because you're looking at that a lot.
I have a binder, just don't break it.
Or snap a picture, have it on your phone.
It's my folder for every subject.
I don't get paid to do that.
How do you fit it all in there? Like, how do you like filter?
By recycling lots of things.
Oh, recycling your labs. Yeah. Got it.
This is true, yeah.